Welcome to our virtual meetup. My name is Pramod Kunju. Today our speaker is Joseph Kambourakis. Joseph is the lead technical instructor at Databricks. Previously, Joseph was an instructor at Cloudera and a technical sales engineer at IBM. He has taught in over a dozen countries around the world and been featured on Japanese television and in Saudi newspapers. Joseph is a competitive Magic a Gathering player. I'm sure there will be a question about that later on. He holds an MBA with a focus in analytics from Bentley University. Today's topic is Spark ML. I don't believe that we have anyone better than Joseph to walk us through what Spark ML is, what its uses are, and everything that's Spark ML. If you have any questions about what Joseph is presenting today, please go ahead and use the Q&A button and send your questions. We usually get to questions at the end of the presentation. With that, Joseph, it's all yours.
Okay, great. Thank you. So I have a few slides that I'll go over to talk about Spark, Databricks, and then we'll go into a notebook and some code. And I'll share all the slides and the code with everyone as well. So with that, so our agenda is I'll do my bio quickly, although it was sort of already covered, and then talk about Databricks, but just sort of one slide, and then talk about Spark, Spark ML, decision trees, random forest, which will be the algorithm that we'll talk about, and then go through a notebook. So I think my bio was pretty well covered, but I live in Massachusetts, so very far from California and Orange County, and these are my kids. They're asleep right now, so it's after 8 o'clock. And I'll talk a little bit about Databricks. We create this analytic platform, and we'll get to see it in the notebook in the example that I do. Huge focus on open source tooling, so original creators of Spark, and we've also created some other projects such as MLflow and Koalas and Delta Lake. And yep, those are our projects. We have, again, thousands of customers, lots of interesting ones. If you ever want to know what customers I like or don't like, that's always a good question that people typically like to ask. And we're still private. We're about 7 years old at this point. I joined 3 years ago. So I'm one of the dinosaurs. One of HR person called me a dinosaur the other day. But the main focus of our company is to support Apache Spark. And that's what we'll be looking at. So Apache Spark is an open source tool that gives you access and the ability to do lots of different things. So for example, you can do streaming with Apache Spark. You can also do ETL. You can do machine learning, which is what we'll focus on. There's also ways to do graph processing and actually treat it just like a traditional database as well. So it's a really powerful in-memory processing tool. And the nice thing is it gives you the flexibility to do all of these things. But we'll definitely talk about the machine learning piece today. So for Spark Machine Learning, the main idea is that you have these different pieces that you can put together to build a machine learning algorithm. So some of them are transformers, ways to encode your data appropriately, to normalize numeric data. Another important piece is the algorithm. So there's a lot of supported algorithms. We'll talk, and I'll show some of the documentation in a moment. But you get traditional algorithms like linear regression, decision trees, logistic regression, clustering algorithms, boosted trees, a lot of the sort of traditional machine learning things. And then within that, you also get ways to do cross-validation, you can do grid search, and then you can evaluate the models. And I'll show a lot of these. Certainly transformations, a couple algorithms, and the evaluators in a few moments. And I have a link to the documentation, which I guess I can show now. And I'm always impressed with the documentation. So the main page is right here. Oh, I actually want the 3.0. So 3.0 is just released. I have a slightly old link. There we go. So Spark 3.0 goes into different examples. You have things about all those transformers that I mentioned. So all of these are a link to a different way to interact with your data. And then a lot of the algorithms are listed here. So for classification, there's 10. For regression, there's 10. Then there's also ways to do ensembles. There's different clustering algorithms, collaborative filtering, pattern mining. So it's actually really, really nicely documented. I'll refer back to it. I have some links in the notebook that I'll talk about as well. So the first algorithm that I'll show is a decision tree algorithm. And I have this, when I was making these slides, I thought, okay, I have to make an entire slide on decision trees. And then I thought, that's been done 100 times. And a friend of mine, Chris Albin, has these really nice machine learning flashcards. And I said, hey, Chris, just give me an image of that. And I'll use that as a slide instead of sort of making my own. So I have a little plug for his website right there. But he draws a much better picture and explains the algorithm a lot better than sort of whatever drawing I would make. And the key idea is that you're trying to classify data. So in this example, you're trying to classify whether someone has cancer or doesn't have cancer, sort of a true or false type of classification. And to determine this, you're going to ask a lot of questions. Are they male? Are they female? What is their age? And that's exactly what the algorithm will try to do. Now, in reality, we're going to build a very much larger one on thousands, maybe millions of data points. And you'll get some inaccuracy with it. So in the notebook that I show, we'll have a very, very small example, and then we'll scale it up. But the nice thing is you can print these out. They're very easy to interpret. You see exactly what the most important feature is. And the most important feature will be this sort of root node right at the top. So very classic algorithm that's been around for decades at this point. But implemented in Spark. And the interesting thing about that is it's built in a distributed way. So it's not a traditional algorithm under the hood. It's built in a distributed setting. So Spark will let you scale to hundreds and thousands of nodes. Again, if you do have questions, just add them to the Q&A panel and I'll get to them shortly. Then there's this idea of, well, instead of building one algorithm, build a lot of algorithms. And that's what the idea behind random forests is. Instead of making just one decision tree, you'll make 100 decision trees. And then each tree will vote, and then whatever the majority is, that's how you'll label things. So now, instead of just like we have here, one tree saying cancer, no cancer, you'll have 100 trees. And then if 51 say cancer, then you'll call it cancer. The trick here is that it does lots of row and column sampling to do that. So you're not just building the same tree 100 times, you're sampling the data to simulate hundreds of data sets in order to do that. So a really, really much more powerful type of algorithm than something like just a decision tree. But again, a lot more computationally expensive. Here we're building one tree, but with random forest, we'll see the argument you can put in. You're going to build maybe 100 or 1,000 trees. And that was really all I had for slides. I really try not to use a lot of slides, and I don't think people learn terribly well from slides either. But I have a notebook that I wrote, and we'll walk through that. We'll see how what the platform looks like, what Spark does, and then these two algorithms. So for this, I created a free account. So Databricks has a way to just make a free account to practice on, and you can spin up a cluster. It's not going to be a gigantic terabytes of RAM and thousands of cores type of cluster, but it's certainly going to be good enough to run this demo and to practice and to learn on. So when you log in, you get to this landing page. It says, welcome to Databricks, and there's some buttons here, different things you can do. Home will show you any notebooks that you have, so I have a notebook right there. There's also the workspace, any recent notebooks, again, just the one for this. And you can actually create a database. So Spark is really flexible in what it can do. And one of the things that it can do is you can treat it exactly like a database. So you can run SQL queries on data just as you would with something such as Postgres. But one of the neat things is you can create a cluster. So I have one that's running right now, and we see it's just a one node cluster since it is a free version. But you can always do things like delete them, create new ones, and I could do that just to demonstrate it. So I'll delete this cluster, and then I'll create a new one. And I'll give this one a name, let's just say Thursday evening. And one thing that we do as a company at Databricks is sort of create different versions of Spark. And so you can see there's different Spark versions here, 3.0, 3.0, 2.45. But what we do is we package them in a really nice, easy way to deploy it on the cloud. And with that, we have some specific things that we'll do. We have one with GPU libraries built in. We have one with machine learning libraries built in. So lots and lots of different sort of built, tested versions of Spark. So instead of having to install software, you can just use this. And that's, for me, really important because my background is more in analytics. I don't know how to create clusters and install software, and I don't know Linux and those kinds of things. So this gives me a really nice, easy platform to work with. So you can just give it a name, pick a runtime, and then it'll let you create. So I think I already have one running. Yeah. So I can just use this running one. But as a customer, and in the full platform, you can create up to 100 clusters. So then I'll just attach, and I think just deleted mine. So let me just refresh. Yep. So I'll create a new one. And that'll take a moment to spin up. And in the meanwhile, I'll walk through some of the code and the platform. So we have lots of different ways to interact with the cluster, but the key thing is that this is all cloud-based. So this particular version is all backed by AWS Cloud, but we also have a platform on Microsoft Azure as well. And so we have a very traditional notebook environment, very similar to like a Jupyter or an IPython notebook that you might be familiar with. And within it, let me make this a little larger, you can have Markdown. So this is like just an image that I have rendered in Markdown. But you can always do things like copy the notebook, create a new notebook, export it. And a big emphasis at Databricks is that you don't get locked into the notebook or the code. So all the code you write, you can always export. All the data in the platform, you own it. We don't own your data or anything like that. So you just have an S3 bucket, and we connect your account to that S3 bucket. So we don't ever keep data hostage or anything like that. So lots of ways to interact, run code. The notebooks save automatically, so you can see I was working on this earlier today, and I've got some timestamps there. So what we'll do in this notebook is read in some data, make a decision tree, visualize it, and then do the same thing with a random forest. And hopefully it'll be very, very minimal code change, ideally. So one thing that I'll do is there's, in Community Edition, you can load data in, and it's pretty easy to do that. There's a button called Data. You could just go into Add, and it'll give you sort of a GUI for adding in data and connecting to lots of other tools. So if you want to connect to Snowflake or Kafka, there's tons of connectors for that kind of thing. But there's also some built-in data sets. So if you're practicing and getting used to it, you don't have to learn how to load in data. You can just look in the file system, and that'll be there. So one of the examples I'll do is with this data set that comes from the Spark Definitive Guide, and it's called binary classification. And so it's in the file system. You see a traditional sort of ls command there. So with Spark, to read data, you give it a path, and you just say spark.read Parquet. And since this is a Parquet file, you can see it is Parquet, it's zipped, and it's actually distributed. We see there's 8 different pieces from 00 to 07. So the nice thing is that Spark will handle a lot of that for you. We don't want to start saying, unzip the file, read piece 1, read piece 2, read piece 3. Reading a data file is pretty straightforward. It's just, hey, Spark, read this Parquet file. And it'll handle all of the compression and the distributed pieces for us. And it'll read in a data frame just called df. So my cluster started up. You saw pretty quick startup time. I'd say maybe about 3 minutes or so. So much faster than something like HDI. So here's our data frame. It is a PySpark data frame since I'm using Python. And I have a label and a feature. And so Spark machine learning requires very specific names on columns. So we're all used to sort of X and Y or input and output. In Spark, the terms for the X or the input is features, and the term for the Y is label. So let's take a look at this data frame. We can print it out right in the notebook. And it's not very impressive. It's really just a small sort of tiny toy data set. And this is the whole thing. We see each row there, 5 rows of data. Here's our label, 1, 0, 1, and here's our data here. So we have just some values. And these are dense arrays. Here, 3 values each. And we can unpack them. So 3 values. And again, we can see how many rows we have with just a count method, and 5 rows. Now we'll get into some of the machine learning pieces. So one thing that you do in machine learning is break your data into a training set and a test set. So we take our data frame, we split it, 80%, 20%. In this case, 4 records and 1 record, since it's a small data set. Then I will import my decision tree algorithm and set it up. So now I have a decision tree object that I can create decision tree models with. And in this case, what I'm going to try to use it for is to classify this data as either a 0 or a 1. One nice thing is that I did post a link to the documentation, and you can look at all the documentation. So in this case, decision tree classifier. And this is actually pretty good documentation. You see it has code samples, and you can copy paste a lot of this right into a notebook and it'll work. But the other thing you can do is just print out the documentation right in the notebook with this explain parameters feature. And what this will do is show all the different knobs and things you can change. So what our label column is, by default, label. How we want to split the tree, what our features column is named, which is features. Lots and lots of different things. Things to prevent overfitting, such as info gain and min instances. And then we can use it to make predictions. So then what we'll do is we'll put everything into a pipeline. And the pipeline gives us this tool that lets us optimize our code and makes it really reusable. We'll see this in some later examples. So our pipeline has just one stage, which is our decision tree. And then we take our pipeline and we fit it to the training set. And this will build a model object for us called pipeline model. So this .fit is a very traditional sort of Python style of programming. And we see it should take a couple seconds. And we can then print this model out. So here's our decision tree. It's not very complex. We have just one feature, feature 0, and if feature 0 is greater than 1.5, we'll label it a 1. If feature 0 is less than 1.5, we'll label it 0. So we get that classifying and labeling. In our case, with just a small data set, 0 and 1, but we'll look at a more interesting case shortly. And so you can print out the tree. with just this display. And then we want to see, well, how well did our model work on our test set? So what we can do is make predictions. Using that model we created, we'll transform our test data and make predictions. So here is our original data, label and features, and then we have our prediction, which is 0. So our prediction matches the actual label, and we can look at a way to evaluate these. So we have a multi-class evaluator, and we can see all the different things that it can do. We're mostly just concerned with accuracy. So we'll say, all right, let's create one with the metric name for accuracy and print out the accuracy of our model. And it'll be 100%, since we only had one record that we got correct. But we see there's other metrics you can get, F1 score, weighted F1, those kinds of things. So this is a really, really tiny example of what you can do. So setting up an algorithm, building a model, printing the model out, visualizing it, and then making predictions and evaluating the accuracy of your model. So that was with the 5-row data set. No one works with 5 rows of data in real life. So here we have another example, and this is a much bigger data set. So this is data for Airbnb listings in San Francisco. And again, it's built right into the platform. So you don't need to install the data or anything like that. It's in automatically. So we'll read it the same way, spark.read.parquet. And this data set is a lot bigger. This is our schema. We have all these different columns, host to superhost, cancellation policy, every different thing you can think of that would apply to an Airbnb listing. How many bedrooms, how many bathrooms, those kinds of things. And it's a much bigger data set. It is 7,000 rows. And what we're going to try to do is predict whether or not the host is a superhost. So we can do a group by count. So just like you can do regular SQL operations. And we see that about 4,500 are not superhosts and 3,000 are superhosts. So we'll try to predict and classify them. We'll do that same process again. We'll say, okay, we'll build a training set, we'll build a test set by randomly splitting the data up. And then our input is going to be how many bedrooms. So if there is a one bedroom in the listing, maybe that means they're a superhost or not. One of the other requirements is that the input data be a vector. So we're going to have to take our bedrooms and make a vector out of it. And there's a helper function for that. So in the transformations, there is a vector assembler. And what it'll do is take all of your inputs and make an array or a vector out of it. And I have the link to the documentation right there. So it takes in inputs and outputs. So our input is going to be bedrooms, and our output is going to be features. And we set up our assembler. So now we took our input and made an array out of it. So now Spark can understand it as an array. The other thing we're going to have to do is tell it that true and false are really levels that we're trying to predict. So we'll index those with the string indexer. And we'll say, okay, take host as superhost, and then the output will be label. So now we've cleaned up our data. 2 inputs, the host as superhost and the bedrooms. We'll still build a decision tree, but now our pipeline has 3 pieces. Cleaning up the label or the target, cleaning up the features, and then our algorithm. And we'll build our model with that same pipeline fit. And again, it won't take very, very long. Over 7,000 rows of data. It took about 7 seconds. And we have a very small cluster. We're not working with hundreds of nodes or anything like that. And the nice thing is that Spark will scale very linearly for us. And then we can print our model up. So here we see, all right, feature 0, if it is greater than 5 bedrooms, or greater than half a bedroom. So if they're trying to rent out less than 1 bedroom, if it's 0 bedrooms, they're not a superhost. And you see this decision tree get built. And then we'll do that same code again. Model transform on our test set, and we'll see what our accuracy is. We can print that out. 58%. Not terribly accurate. So one thing we can do is make a more complex model. Instead of just bedrooms, we'll look at more columns. And we'll look at just putting in numeric ones. So everything that's a double. Host listings, latitude, longitude, accommodates, bathrooms, all those kinds of things. So I have just a list comprehension that will make a list of all the columns that are doubles. So all of these are columns, and it's going to be quite long. We can do a length of this. So 27 inputs now to our model, as opposed to just bedrooms. And we're going to really just keep reusing the same code. So we still do assembler, we still do pipeline model, label indexer, assembler. So a lot of this then just becomes copy pasting a lot of your work. And we'll see this again and again. And then we have the same code as before. Pipeline model, transform on test df. What's our accuracy? No better, 77%. So our accuracy before was, okay, it's better, but for adding in 27 columns, I don't know if we got that much better. So now we'll take the same stuff we did and just put in a different algorithm. So I'm going to try the random forest one, and I'll build 100 decision trees. So I set up my RF there, and then it's the same code, except I changed DT to RF. So if we look right here, here I had DT. Now I'm going to use RF. The same vectors, the same label indexer, same code, pipeline model, fit, train df. And now it's building 100 trees, 100 decision trees. And should take about 8 seconds. So pretty quick. And then the same exact copy pasted code to get my accuracy. And 77% again. So it seems like building 100 trees wasn't that helpful. But the neat thing is we built 100 trees using an open source tool, using a free community edition provided by Databricks, and really an interesting kind of way to practice, prototype, and sort of get experience with it. So I did want to leave some time for questions. And again, I'll provide this notebook as well as some links. I put the link on the Meetup page. So if you go to the Meetup page, there's a link to a Google Drive that I hope works that has both the slides and that notebook. And the slides do have a link to the free version that we were using. So if you do want to reach out to me with any kind of questions, my email is josephk@Databricks. As Pramod said, I'm not a salesperson. I work in training, so I deliver just customer trainings. I don't get commissions or anything like that. So I'll certainly tell you the truth if you ask a question, and I won't try to sell or schedule meetings or anything like that. So feel free to email me with any questions about Databricks or about Spark. And I have the link here to the free account that you can create. So with that, if you have a question, please put it in the Q&A of the webinar, and I'll try to answer it. And again, I'm pretty open. So if you have a question, I don't know, how many employees work at Databricks or something, I'll be happy to answer.
Yeah, I'll ask a couple of questions here, Joseph. Very fascinating to start with, very fascinating demo. I have worked with Jupyter Notebook, and this kind of reminded me of that.
Yeah, so it is a fork of Jupyter Notebooks. We just have some other pieces added in. So one thing I didn't show is you have the ability to write other language code, but just type in the language. So if you want to write R code, you just do %R, and then you can make an R code. So it's kind of neat in that you get some flexibility. You can also do SQL code as well. So you can change languages within it. It's one kind of neat feature.
Got it. So in terms of one question that I was thinking about is you spoke about the decision tree and the random forest. Are there other algorithms that can be used, or
Yeah,
The
so the
limited
list of
structure.
them is in the programming guide. So there is logistic regression and naive
Okay.
Bayes, quite a few. And then there's different clustering, collaborative filtering ones. Um, so yeah, lots of different
Right.
algorithms. Spark by itself doesn't support deep learning, but with Databricks, there's some libraries that will help you to do deep learning, and you can use it for that. But Spark is more of like an enabler than like a deep learning tool. But you can find lots of documentation on deep learning.
That makes sense. There is a question from Chitish about.
Yeah. Okay, so let's see.
Are you able to read it?
Yeah, I can see it. So it says the demo you showed was a Spark 3.0. Yes, so it was Spark 3.0, which was just released on June 18th. But most of the code shouldn't matter too much. There wasn't much that broke from 2.4 to 3.0. So if you run this on a 2.4 cluster, it'll certainly work. But yeah, we released it on June 18th. It was 3.0. There's another question from Gotham. I just graduated my MBA. I'm starting to get learning with machine learning and AI. Do you have any suggestions on learning AI? Yeah, so I would say, and Mike, give me a second. Francois Chalet has a really good book that's like Deep Learning with Keras. And I think that's the best book. He's a researcher at Google. So I'd recommend that. And I don't get commission for that book. Another good book is DL4J by Adam Gibson as well. And I can post that in the meetup. But yeah, so this book here, Deep Learning with Python, it uses Keras. I bought it a few years ago, and I think it's just still a really good resource. And the best thing is just sort of write code and practice and read. And I think, and ask people for help is also another big one. And what else have I any advice?
Yeah, one thing I've noticed, I would like to weigh in on that as well. There are a lot of courses that have now gone virtual thanks to COVID. So you may want to try some of those courses. I know there is one from Stanford, which is part of a certificate program, but you can also take individual courses. I put in my email address there, Gautam, if you would like to ping me, and I can send you some links.
Yeah, there's certainly tons of resources for learning. At Databricks, we do have a deep learning course that's Spark specific, but you could answer those kinds of things as well. Right. And Chats, it says, yeah, Data Science for Business is a good book to start. I don't know that book, but lots and lots of good books. If you do want a Spark book, there is actually a brand new one that just came out recently called Learning Spark 2. And it was released this month in July. Oh, there might be a free link actually. Oh, this is a preview, but this book's really good. I work with the authors a lot, Jules and Brooke and TD and Denny, so I'd recommend that. Let's see. So Dwayne asks, what's the 3.0 roadmap for Azure Databricks? Are the parties involved promising parity? Yeah, so the 3.0 release did happen on Azure a couple weeks ago. It is there. I used it yesterday. And yeah, so feature parity, as far as Databricks, the same exact code will work on either platform, and we don't care as a company which platform you choose. The differences are sort of like the VM names are one difference, but very, very minimal difference from our perspective. Everything under the hood, because it's a different cloud, it's a different data center, it's different, but the platform doesn't look very different at all. It's this, and it says like Azure on it. And we try to keep feature parity so that customers don't have to make a decision and say, well, if I go with this one, I won't get this feature. So we try to keep it exactly even in that regard. Yeah, so this free account is, it's just really for learning. You couldn't do any production stuff with it. But it's really good for learning, for demos, doing a class. We definitely have universities that use it. At the very least, it's a really nice Python environment. So if you just had to write a bunch of like pandas, you could do it in that platform. All right. Any other
All
questions?
right. I have a question. I know that you said some data sets are automatically installed. You showed us the Airbnb data set.
Yes.
Can you give us a flavor of what else is out there?
There's a ton of them, actually.
Okay.
I can show this quickly. So what you would do is to look, the command would just be file system ls Databricks datasets. And you can't have malformed quotes is one thing. So let me just change that. So there's data sets for COVID right there. There's ones for, this is like different kinds of adults and salaries, airline data, Amazon movie reviews, bike sharing data. I don't know what this, maybe videos, credit card fraud, some courses. The one we used in the definitive guide, this is flights, pictures of flowers, some genomics examples, IoT, lending club loans, MNIST, which is like a traditional image data set in black and white. I don't know all of them, but there's a lot built in. So you can certainly get started in learning. And the nice thing is those books do have data sets tied right into the platform. So if you got the definitive guide, the data sets are right there. You can code along with the examples.
Got it. So these are data sets that you have acquired as a company, or are they publicly available? Do you know?
They're typically publicly available.
Yeah.
Okay. For examples, and there's a lot of, if we wanted to add one, so if I wanted to add a data set to this, I'd need to go through legal to make sure it's like an open data set and those kinds of things. But yeah, you can add your own data to the platform. And there's certainly connectors to all sorts of tools, such as Tableau, or if you wanted to read from Postgres or SQL Server or Cosmo. A lot of what we do, and that's kind of outside of Spark, is the ability to connect to other tools, because Spark is just the processing engine. So we'll make something like a Kafka connector, those kinds of things. But yeah, Dwayne says he missed a few minutes. Yeah, the video will be posted on YouTube, and I'll post the resource links in the meetup page. All right. So if anyone has any other questions, my email is josephk@Databricks. Feel free to send me an email with any questions. Oh, I should note we are hiring if you're interested. We don't have any hiring freeze or anything like that with COVID. We've been onboarding people just about every single week. And we're also mostly remote. So our headquarters is in San Francisco. I've only been there once in the past couple of years. So big remote emphasis as well.
Yeah, I wanted to ask you one more question. I know this is probably too much detail, but I did notice that when you did the random forest algorithm, you had to specify the number of decision trees. I think you did 100.
Yeah.
So is there a way the tree itself can kind of determine or tell you the number of, or the forest can tell you the number of trees that are needed?
No, for something like that, you'd really need to grid search it. So what you would do is, instead of building 100 trees, you build one with 10, one with 50, one with 100. And then the documentation for that is in model selection. So it's pretty good. It'll tell you how to do cross-fold validation, how to build a parameter grid to search, which is right here. So you do like just random forest, num trees, and then .build. Yeah, not quite enough time for grid search as well. But yeah, you can do grid search with open source Spark and that sort of brute search, force grid search. We do have something available on Databricks Labs, and I'll post the link to that, that does Bayesian search. So I'll grab that. Make a note to grab that.
Okay. Again, Joseph's email will be posted on Meetup. If you have any further questions, you can reach out to Joseph directly. I do want to thank Joseph. He's on the East Coast, so pretty late for him, but he took the time to talk to us about Spark ML, which I personally found very fascinating. If you missed the Meetup live, please do watch the recording. and you can follow up with Joseph with any questions. Thank you very much, Joseph. Thank you.
All right, have a good night or evening.
Good night. Thank you. Thanks, everyone. See you next week. Thank you.